All right, so let's take a look at number 35. So 35 kind of is going to bring us into a little bit, somewhat, of what we're going to be doing in the next couple chapters, for sure, sections, for sure. It's a story problem. All right, so you needed to handle this just like you would if this was an equation. All right, so they tell us that we have a $20 bill to spend. Come on, everyone's looking at number 35. With a marking pen in your hand, Joseph, come on, get to 35, please. I don't know why we're just not in our homework. Come on. The marking pen in your hand. Come on. This is not that hard. All right, they also tell us that we have 3 people. 3 students, I think is what they tell us. All right, and they tell us that we get change after paying. All right, and then they tell us that we want to write, they also tell us that T is the cost per movie ticket. And we want to write an inequality to represent this. All right, I'm going to do this the same way I do an equation. If you notice, because all of you should be, as you're writing this stuff down, you're thinking, what things are we measuring here? Come on, put the rulers down. They're not toys. What things are we measuring here? Come on, everyone's listening. Everyone's reading what I wrote on the board. What things are we measuring here in this story problem? All of you, look up at the board. Sophia, look up at the board. All of you be willing to think right now. Read through the givens that I've written there and tell me, what are the things that we're measuring here? Grace? All right, so we have a cost per movie ticket. How many of you guys agree that's one of the things we're measuring here? What else are we measuring here? Ben? Money. Aren't we dealing with money? Right, we have $20 to spend. What else are we measuring here? What other things are we talking about here? Joseph? Yeah, we've got how many people, right? We have money to spend. We have number of people that we're spending the money on. So when we have 2 different, put your hands down, when we have 2 different units that we are talking about here, what operation have I told you guys you should probably be doing if you have 2 different units of measure? Addition or multiplication? We've already talked about this. Remember, we talked about story problems. We talked about what to look for. All right, when we have 2 different units of measure that are being measured here, am I going to have multiplication or am I going to have addition? Jacob? Multiplication. What else indicates up there that we're going to have multiplication other than the fact that we are dealing with money and we're dealing with people? What other thing up there indicates I totally have multiplication here? Hannah? Excellent. That, Jacob, that is a rate. And Hannah, you're absolutely right. That indicates multiplication. All right, so we're going to start with our game plan, just like we would if this was an equation. So we have a parts equal to our whole. What information here is our whole? What information here is our whole? Francesca? The total to spend, right? Absolutely. This is our total to spend. What are my parts? Come on, you guys. What are my parts? Stop playing with your hair, ladies. Think about what I'm telling you. What are my parts? Evan. Pardon me? My number of students. What else? Alex? Nope. That's my total to spend. What do I know is always a part? That I have to multiply by those number of students. Ava? No, not the change. Come on, you guys. We've already identified it up there. What do I know I have to multiply my number of students by? I could say my number of tickets by. What do I know I have to multiply that by? Jacob? The amount per ticket. This is my cost per ticket. And if that makes it easier, let's say our number of tickets here. And that's the same thing as our number of students. That should be, the moment you see that rate, you all should be like, oh, I totally have to multiply that rate by my number of tickets. That should be innate to you, or hopefully getting to be innate to you. All right, I don't know my cost per ticket. That was our T. So somebody write this equation for me, just like it stands right now. We'll talk about the inequality part in a second. Somebody write this equation for me. Jacob? Put the numbers in, sweetie. Fill it in. T equals, excellent. All right, so, but they told us to write an inequality. So what does that mean about our 20? Can we spend more money than our 20 or less money than our 20? Ben, you're listening. When we're talking about our 20, that $20, and we'll talk more about this the more we get into story problems, but that $20, is that the most that we can spend or the least that we can spend? Maya? Yeah, that's the most that we can spend. So what does my actual that we are spending money on? This right here, that 3T, that is our actual that we are spending money on. What can our actual that we are spending money on be in relation to that maximum? Lawrence? Well, I agree with the less than, because I can't go over it, right? Now we've got to look and see, should I have an equal to? So go back up into our story and read a little bit about that story and decide, can I spend exactly that $20 or not? Exactly. We need to get change back. So this is not equal to. It's just 3T is less than 20. We'll be doing more of those the more we get into these story problems, okay? All right, put this away. Get your notes out, please. How many of you guys are pretty confident with your understanding of graphing solutions, inequalities? Awesome. Jacob, did you get the notes from yesterday? Okay, so you need to get the notes from yesterday. You know, they're on YouTube by the end of the day. So you guys, if you're ever absent and you feel well enough, get on YouTube. Look at our lesson for the day. Take the notes. Stay current with us. I am expecting that you guys are doing that. Okay? So I need you staying current with us, please. So take those notes. Do that homework, please. Sophia, why are you getting loose leaf out? Why are you not getting a math spiral out? Where is it? You have math today. Where's your math binder? Why are you not prepared for my class? Okay, if I keep seeing you having to do stuff on loose leaf, I'm just going to mark you down on the next homework assignment. I'm expecting all of you to be prepared for my class. Every once in a while, not being prepared is fine. Constantly not being prepared is a huge problem for me. All right, so today is the 31st. All right, we are moving on to Chapter 2, Section 9. And we're going to solve one-step inequalities. With addition or subtraction. So we're going to be solving one-step inequalities with addition or subtraction. Maya, is that your protractor on the ground underneath you? I just don't want you to lose it, sweetie. Okay. So here's the big statement that I have for this. For inequalities, with addition or subtraction, the process of solving so for inequalities with addition or subtraction, the process of solving is exactly the same as equations. There's no difference in solving equations versus inequalities when there's addition or subtraction. When I have multiplication or division, that will change. So we'll start with the easy ones. Come on, Joseph. All right, so let's just go ahead and graph. We're going to graph and then solve the solution. I'm sorry, we're going to solve and then graph the solution. That was totally backwards. So we're going to solve and then graph the solution. So you guys need your rulers. So I have my first example is going to be x plus 8 is greater than or equal to 19. So all of you graph that, and then I want you to graph your solution, please. So solve that and graph it. Remember, you solve it exactly the same as if it was an equation. Same process. Remember, if you're counting by ones, all I need to see is the 0 and the start number with increments in between there. If you're counting by anything other than ones, I need to know what you're counting by. So if you're counting by 2s, you're going to put a -2 and a +2 on either side of the 0. Somebody tell me, how do I solve this? I'm hoping this is easy for you because we've already done one-step equations. How do I solve this equation? Alex? So I'm going to add a -8 to both sides, right? Is that what you mean? Excellent. So the 8 and the -8 cancel each other out. I'm going to drop that requirement that you show 0 there. You just know that you did that. So I have x is greater than or equal to, what's 19 plus a -8, Alex? Excellent. So my x is greater than 11. X greater than or equal to 11. Remember, you're graphing that solution. So Alex, where would I put my dot? So where would I put my dot? What number would I put it at? 11, because that's my start number. I counted by 2s. That's just me. If you counted by 1s, it's fine. So 2, 4, 6, 8, 10. Here's 10. Here's 12. So here's my 11. Is a closed dot the right thing, Alex? Or should I do an open dot? Why closed? Excellent, because it's greater than or equal to. What are all my x's, Alex, in relation to my 11? Are they bigger than my 11 or are they smaller? They're bigger, because the bigger side of the inequality is facing the x's. So I'm shading everything to the right. Excellent. Questions on that? All right, let's do another one. N minus 15 is less than 3. So solve and graph that, please. When you're done, check with someone sitting by you. I'm hoping all of you started by adding a negative, changing that subtraction to addition, and the number after to its opposite, so n plus a negative 15. All right, who wants to solve this for us? Go ahead, Lawrence. So I'm going to add 15 to both sides. Excellent. So the 15s cancel each other out, right? Excellent. No, not n plus 3. First it's n plus 0. Right? But I don't have to show that anymore because you guys know that. So I have n equals, Ben, sit up, is less than, and then 18. Excellent. You went by 2's? How many of you guys went by 2's to graph this? Excellent. So I'm hoping that you remembered. You're going to put your 0 on there, and then you're going to, to the right, you're going to show a positive 2. To the left, you're going to show a negative 2 to indicate you're counting by 2's. All right, 4, 6, 8, 10, 12, 14, 16, 18. So here's my start number. Tell me the dot, sweetie. Why is it open? Excellent. And then what are all my n's in relation to that 18? They're less than, so I'm going to go to the left. And again, you're just going to darken that. You don't have to go all the way to the very end, just as long as I can see which way you shaded. How many of you guys got that right? Fantastic. So I'm going to give you 4 that I want you guys to do. And then actually, I'm going to show you how to check your solution. They may or may not ask you to check it, but we've got time, so I'm going to teach you guys how to check your solution. All right. So just to the right of this one that we just did, I'm going to show you how to check your solution. When you're checking your solution, this is a little bit different than it is an equation. All right, if this was an equation, and we had n minus 15 is equal to 3, and we found n is equal to 18, how would I check my solution? So if this was an equation, and this was our equation, and this is what we found for our solution, how do I check that I got that solution correct? Talk with someone sitting by you. What would you do? What would you do? So what would you guys do to check if 18 is the solution to this? Come on, you guys. Francesca. Nope. I already solved it. I already did all of that. I already added 15 to each side. This is what I got. But I want to check to see if I did it right. What am I going to do to check to see if that is a solution? Suzanne? No. Nope. I'm not solving this equation. I already solved it. What am I going to do to check to see if I did the right math? Grace? No. What am I going to do to see if that is a solution? Alex? Nope. How am I going to check to see if 18 is a solution to that equation? Come on, you guys. Sophia? Nope. 18 divided by 3 is 6. Why am I divided? Nope. What does this equation say? Someone tell me, what does this equation say? Morgan? Excellent. What did we find was our n? 18. So, how am I going to check to see if that's the right solution? Morgan? No. I already did this. I already did 15 plus, adding 15 to both sides, and I got n equals 18. How am I going to check to see? Maybe I subtracted these by mistake and I came up with 12. How do I know I did? This is a solution. Evan, put what in the equation? Yes, I'm going to take that 18 and I'm going to put it in for my n. Doesn't that make sense? And you're going to look to see, if I add 18 and negative 15, do I get 3? That's what we've done this, you guys. We went through an entire section. Put it down. We went through an entire section of checking to see if an answer is a solution. Don't you guys remember this? Okay, then why don't you remember it now when I ask you? All right, so checking a solution to an equality is different. So what we're actually doing is we are just checking the shading to see if we shaded correctly. That's all I'm doing. So the first thing I want you to do is I want you to choose any value from shaded area. All you are taking notes right now. Everything I'm writing, you're writing. So choose a value from the shaded area. What would you like to use? So take a look at our shaded area. You can use any number you want in that shaded area. Choose a number. Annika, 12. So let's choose x equals 12. Then what you're going to do is you're going to substitute that value into the given to see if it makes it true. So you're going to substitute. Annika chose that 12. You could have chosen 1, you could have chosen 0, you could have chosen 17, any number in that shaded area. You're going to put it in for the variable, and you're going to see if it makes it true. All right, so I have 12 plus a negative 15. We're looking to see, is that greater than 3? Or is that less than 3? I'm going to put a little question mark over that. Well, what is 12 plus a negative 15? What's 12 plus a negative 15? Joseph? No, it's not 3. What's a positive 12 plus a negative 15? Negative 3. So I have negative 3 is less than 3. Is this true? Is negative 3 less than 3? Yeah, that's true. So what that tells us is we shaded correctly. So this is true. So we shaded correctly. You guys cool with that? Grace. I just shade, yep, I do my shading. No, you see how far I went? Do you see how far I went? So does that answer that question? Did I go all the way down? No, you don't have to go all the way down. No, of course not. I'm just looking at the shading. You can make that shading as long as you want to make that shading. Don't make it too short that I can't tell the difference between a shade. Put your hand down. The difference between the shading and your dot. It can be as long as you want it to be. All right? I just need to be able to see it. Just sit still. I just need to see the shading. Ava. I can't hear you because I'm talking. Okay, tell me again. Yes? Okay, so if we have an open dot or an open dot is when we have a less than symbol or a greater than symbol. A closed dot is when we have the equal to as well, the line underneath it. Does that make sense? All right, so you two, anybody, if you're absent, you guys need to take the notes. If you have not already, if you did, that's awesome. Look back in your notes if you need to when you're doing this. All right, but you need the notes from yesterday. So Jacob, you need your notes from yesterday. So before you do your homework tonight, I recommend you look at those notes and take notes from yesterday. Okay? Okay. All right, so what I want you guys to do, I want you to solve the following 4 inequalities. I want you to check the last 2. So you don't have to check all of them. So I'll circle the ones I want you to check. So I want you to solve and graph the solution. So solve and then graph the solution. All right, my first one is 8 plus t is less than 15. So go ahead and get started on that one, and then I'll put the other ones up. So I wrote the word check next to the ones I want you to check. So there are all 4 of them. You guys should be using your rulers. I should see your number lines on grid lines. I'm really picky about graphing. Your number lines should be on grid lines. You're using a ruler to draw your number lines, please. All right, make sure that you can see exactly what the dot is and what the shading is. Let's take a look at some of these. I know you're probably not done. All right, but we're going to need to move on. If you didn't check, that's not the end of the world. All right, so someone come up and show us what you did for number 1. Who'd like to show us what they did for number 1? All right, Lawrence, come on. All right, so I'll just put this out of the way. Okay, so put yours up here. I'll cover this up so you can explain to us what you did. Go ahead.
So I took my 8, I added negative 8 to get 0, then I added negative 8 to both sides, and I got 7, and then I did t is less than 7, and then I drew my number line, and I marked 7, and I put it in an open circle because it's not equal to or less than, it's just less than, and I made an arrow to the left.
Excellent. How many of you guys agree with this? Very nice. Nice job. All right. How about number 2? Who wants to come show us number 2? Come on, you guys. Be willing to show us your work. Jack, come on. Even if it's not right, I'm all good with that. I don't care if you have it right or wrong. This is us talking about how to do it. All right, so number 2. Let's cover that up. Number 2 there. Okay, explain to us how you did number 2. You all pay attention.
So, first I did adding the opposite, so that it's plus a negative 5. Then I added 5 to that to make it 0, and did that to the other side, and I got 16. So then I got x is less than or equal to 16. So then I counted by 2's and marked 16 on my number line. And then I put it going to the left because x is less than.
And what type of dot do you have in 1?
Closed dot because it's less than and equal to.
How many of you guys agree with this? Very nice. Excellent. Who would like to do number 3 for us? Come on. Who did number 3? Who's finished with number 3? You guys aren't finished with 3? Okay, Jack, come show us what you did. Did you finish 4 as well? No. Okay, let's do 3 then. Okay. No, we don't leave till 11:30. And we can't be there until 12. Oh. So we've got a while. No, because I will have 8 today. Today's Thursday. Okay. Yes, so that's for 8x. Yes. Yes. All right, tell us what you did on 4. Are we on 4 or are we on 3? 3. So all of you take a look at his 3. Go ahead.
So
no one's put anything away and you're not packing up. You're listening.
I added 3 to the negative 3 to make it 0, and I did that to the 6
Georgia, sit down.
and got 9, and so I got m is greater than 9. So I counted by 3's and put my 9 on my number line and made it an open circle because it's not equal to. And then I made the arrow going to the right because m is greater than 9.
How many of you guys are cool with this? All right, how many of you guys are pretty comfortable with doing this? Fantastic. Thanks, Chap. All right, you guys can go.